Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench, there's a NAD, NAD 3150. Now I know I'm going to upset the NAD fanboys here, but I got a love-hate relationship with these NADs. When they're all tuned up and they're working perfectly, they sound fantastic. I love the sound of these things, but I just can't get past the looks and the build quality and the quality of parts they use. It just doesn't work for me. So I would never actively seek out a NAD for my own use, although I do love the way they sound. I've got to give them credit for that. They really put all their effort into the design of the circuits and really nothing else. But this is an ad. This one came to me from my friend and client Marcel, and he brought it to me. He says, I don't even know if there's anything wrong with it. And to tell you the truth, I don't know if this is something he picked up off a local buy and sell or what. But we're going to try it out here. I got it connected to everything. Let's get our speakers set up, and don't even know if this thing works. It is heavy. It's a heavy unit for its size. It's got a lot of bulk to it, a lot of mass. So I don't know what these do for power, but it seems like it's ready to do the business. So let's turn this thing on. I got it all connected. And let's see if it flies or fries. Okay, I'm going to turn the volume up a bit. I got a tone feeding in. And plugging it in would help too, I guess. You spend all this time prepping for the opening intro and then I don't even plug it in. Okay. Can you read that? No, you can't. So there it is. Let's turn it on. Jumps up to 67 watts, back down to about 25. Ooh, 67 watts. That's high. Both channels are working. Ooh. I lost a channel. Lost my right channel. I'm back. Ooh, okay, I'm shutting this off because switching speakers on and off, I can hear a lot of DC on the left side, which is not a good thing. Should have checked that before, but whatever. So we got problems. We got probably a relay, right channel dropped off. It was working, but then it didn't. This low level thing, what is this low level? I don't know what that is. And when I played with the switch, it went out. Lost the right channel. Got DC on the left channel. Yeah, we got our problems for us. So we're going to get into this. Probably, if you want me to make any predictions right now, I'm going to say caps are garbage because NAD put garbage caps in their equipment. That's a fact. And at this time of this stage, they're probably all cooked too. So they were garbage and they're cooked. So there you go. So let's have a look inside. Top is quite scuffed up and scratched. It might benefit from a polish. But the paint job on this is pretty horrendous. I don't know what NAD is. It looks like it was powder coated, but it really looks like a poor job. Lots of ventilation on the back half of the panel. A lot of heat. Ooh, look at the cook marks on here. And that is, where is that? That's over here. This little regulator here. So what we got two transformers. Look at that. Dual power supplies on the NAD. Wow. Things are looking up. We got one big main board here, and we got two zones that are cooked. This zone here looks like this resistor is cooking everything around it. And then this zone here where they got these two transistors. They're probably regulators, and they're cooking everything around it too. And I'm pretty much guarantee these caps are fried. Well, all the caps will be fried. Here's another big bulk cap beside a heatsink. So yeah, this is going to be a recap for sure. I don't think any NAD can be passed over without a recap first. Okay. But the bones are here. Everything's nice. Looks like we got good heat sinking, good filtering, good power supply. So everything here is good for making a decent amplifier, but it looks like it was just baked. Everything's baked. You can see on the underside of the bottom plate, we've got ventilation on one half, and this side has no ventilation. So you can see where the air has been trying to get across from one side to the other. You can see all the air lines and how these two pieces of foam rubber are blocking the airflow, and it's all trying to funnel through the middle here and then separate. Here is the underside. We got some meaty transistors here for each channel, and not much going on under here. I do see some, if I look hard enough I'll probably find cracks, but you can see the cook zones here. This side back here is all good. What's the switches back here? Yeah, the switches are back here. Because the shaft comes, I can see the shaft. Here's a switch here. There's a switch here. Was that part of the same switch, or is that a different switch? There's no shaft for this one. But we do have switches on the back that needs attention. These ones here, like we got moving coil, moving magnet. These switches sit in one position for years and years, and then they oxidize, and then eventually they lose connection. So we got to treat all these switches at the back, especially this one here that's locked in one position only. But yeah, we're gonna fix all this up. And the speaker connector's kind of mangled here. It's broken or something. It doesn't feel right. It's locking in the open position. See if we can do something with this. I might have to replace this or think of something else to do with it. So for right now, I see the main problem is these caps. So I'm going to start pulling them out and replacing them. And then we'll take on troubleshooting from there after we get new caps in. Just going through this, and it's not making sense to me. I'm looking at this scorch mark here, and why is it so burnt up? Why? So let's have a look at this circuit the way I found it and the way it should be. Okay, so here I got it drawn out. So what I did is I drew this out because I don't have a schematic. I just have a photograph of a schematic, and it's pretty blurry. So this is the protect circuit, this is the protect relay, and this is driven by this IC701. So it's fed with plus 45.7 volts, it goes through the coil, and goes through a dropping resistor, and then it goes to pin 6. So when the circuit determines that it's okay to come out of protect, it grounds pin 6 or pulls it low, and that pulls on the relay, allows current to flow through. When IC701 detects a fault and goes into protection, this pin 6 goes high impedance, and the relay drops out, and in its place the current flows through to this LED, which is the protect LED that lights up. Now I found this R676 is supposed to be 680 ohms at 2 watts, but I measured at 433 ohms. Okay, so that one's shot. That one's gone. Also, somebody, it's not in the schematic, but somebody tacked another resistor across the relay coil, and it's supposed to be 1K, but it actually measures 1.1K. Alright, you're probably thinking, well, what difference does that make? Well, it does a lot of things. With 45 volts and this pin at 6 at ground, we should have about 30 milliamps flowing through this string to pull this relay contact in. That's if everything's correct. But the way it is now, let me do the math and I'll come back and I'll tell you what it is. So if I do the calculation of this 1.1K resistor and this 1.07K coil resistance, the effective resistance here is 544 ohms. This here is supposed to be 680 ohms, but this resistor changed to 433 ohms, so that puts us at what does that put us at? 977 ohms overall. And if we do the math, 45.7 volts through 977 ohms, we're going to get something like 46 milliamps, when it actually should be down at 30 milliamps. So there's extra current flowing through this. And considering we've got extra current flowing through here, we're also going to have extra power dissipation, because we no longer got 30 milliamps, we got 46 milliamps at the same voltage, right? So what I'm thinking of doing is get rid of this resistor. I don't know who put that in there. I don't think it's not on the schematic. Shouldn't be there. And let's adjust this resistor, 680, until we get 24 volts drop across this coil, even less, 23, maybe 22. The relay will pull in as long as we got enough voltage here. So if we get from 22 to 24 volts across this coil, it'll pull in, and we just need to figure out what this resistor needs to be. 433 is no good, because that's too low, too much current. If we put the 680 in, I'll have to redo the numbers. Let me redo the numbers. Okay, so I did the math. To get the voltage across this coil to be 24 volts, we need approximately 22 milliamps current draw on this leg. To do that, we're going to need to change this resistor from a 680 to something higher, probably somewhere around 1K. I tried 680K this is 680 ohms already, and I put the figure of 820 in, and it didn't change the current enough. It went down to 26 milliamps, not 30. So if I change this resistor to a higher value, we'll have the correct current and a lot less power draw on this circuit. So I should look up the specs on this master sheet relay. Maybe it's got a data sheet. DC 24 volts. Put 24 volts across it, it should only draw 22 milliamps. This here resistor is toast. And then if I look on the other side, I'll show you. Here's the resistor somebody tacked on. It looks like a 1K, but it measures 1.1K, and they tacked it across the relay coil. I don't know why anybody would do that. It doesn't looks like it was maybe factory, I'm not sure. But we're going to remove that as well. Alright, one thing I'm going to do is I'm going to remove all these devices, these power output devices, and I'm going to take them off. This heatsink compound is completely turned hard and crusty. There's absolutely it's not there anymore. So I'm going to take them all out, check their gain, make sure they're all good. Seen a lot of things that concern me. Some of these transistors on these teeny little heat sinks, they might be cooked as well. I'm going to pull some of these out and test them as well. There's these little short heat sinks. I'm going to upsize these heat sinks. I think there's 4 of them here. Oh, hang on. There's 1, 2, 3, 4, 5, 6 of them. And I think they would benefit if I upsize the heat sink, give it better cooling. I'm going to check those transistors, make sure they're not toast, because everything else in this thing is baked. I wouldn't be surprised if they are too. So I'm just about done capping. I got 1, 2, 3 left, I think. And then I have the phono board to do. This comes out as a module, plugs in with connectors. It's really nice. But it looks kind of like a mess on the back here. So I'm going to clean this all up. I'm going to clean this up. This is a mess. And recap that as well. And then I'll move on to switches. I got to move, all these switches are in the back. These are all function switches. This is a tape monitor switch here. I'm going to make sure they're all good before we give this back to the client. And then we're going to be done. We still have to investigate why we had heavy offset on one channel, DC offset. Why we had so much power consumption. This thing was really sucking power when I turned it on. So probably got a high bias. So I'm going to check these drivers too, make sure they're good. There's 4 drivers here, and they don't look like they're heat sinked. That's odd. You would think that they would put some kind of little heat sink on that just to keep them cooler. Alright, update time. Been doing lots of work. I'm busy. What I did is I removed a bunch of the heat sinks. These ones, I'll show you all of them. These pathetic little things are little channels of aluminum. They really don't provide much surface area. So what I did is I removed them and I replaced them with something that's going to really work. These are about 1.5 inches tall, and they're black anodized aluminum heat sinks. Cut them to fit, cut them to width, and yeah, they fit in there really nice. And they're going to dissipate a lot of heat. These will really keep this cool. All these transistors were baked. I tested them, they're all fine in HFE, but you can tell that they were suffering a lot of heat damage. But that's done. I'm working on switches right now. Completed the 2 rear switches here. Gotta say, I'm not pleased with this heat sink. It's sharp like a razor blade, and I've sliced my hand open a few times on it already. I gotta clean some blood up back in the corner here. I'm not pleased at all. So these switches are done. This switch here in the top corner, this is the photocapacitance switch. That one needed cleaning. I still want to do one more switch down here, the stereo mono, or the stereo bridge switch, the bridging on off. There's a switch down there in there. It needs to come out and get cleaned. All the switches are heavily oxidized with black, the black oxides. So I'm surprised it was working at all. Phono board is done. This phono board is all complete, ready to go back in. Not much to say about this. It's pretty simple. I cleaned this up quite a bit too. All these transistors were really tall and they were falling over and stuff, so I sunk them down on the board and resoldered everything, and it looks a lot better. What else? Filter caps. I did test the filter caps. They are bang on 4700. They're going to go back in. There's no need to change these because they're working fine. The relay though, the relay was not fine. I measured one side, it was measuring in the contact resistance was in the mega ohms, and then the other side was in the hundreds of ohms, so that relay was bad. So I'm going to get cracking and clean that. These switches are done, they're put back in, and another thing I did is I removed all the driver transistors and output devices, and well, these aren't drivers, these are more like temperature compensating for the biasing circuit. But everything has been cleaned and regooped with new thermal compound. That has to be all resoldered. Got to resolder all the switches, and after I put the caps and the relay back in, we're ready to go to town and power it up. So I'm getting quite a bit done here. A lot of work on these NADs. I shake my head every time I see these things. There's such basket cases when they come in with the dead caps and the switches that are barely working, and I don't know, crack solders everywhere. These NADs are just terrible build quality. Okay, here's some more ranting about NAD build quality. So you can take pretty much any one of these joints. Well, the most part they're okay, but a lot of these joints are just garbage. The solder joints I'm talking. Now look at this here, for example, this pad. This pad is only half covered with solder, and this pad is only not even a quarter covered with solder, and the rest of the pad is tinned, I think. The reason this is like this is because the poor soldering quality in the factory. Now, either when they put it through the wave solderer, the flow of solder was either too cold, or the board was too cold, or they didn't have enough flux to get this to bond properly. So it only stuck to a portion of the pad, and the rest of it, there's no solder. And a lot of these joints here, if you look at a lot of the joints, they have solder only in the middle, the circle. I fixed up a lot of these already. So, like this one, for example, you can see there's a smaller circle inside where there's solder, and then there's a big circle around where there's nothing on the pad whatsoever. That's a weak joint because you have a low amount of solder holding that lead in place. If you're going to have a circle that diameter, you're going to want it filled with solder so you have some mechanical strength. Here's another one, and another one. Like I said, I fixed up a lot of these already. because they were really pathetic looking, and a lot of cracks as well. If I look down here on these switches were really bad. They were poking up through the board, and they had this wimpy little amount of solder holding the pin, the base of the pin, to the board, and the majority of the pad wasn't even covered with solder. So I reflowed all these and made sure that they had enough. But some of these were cracked. Oops, sorry. Some of these are cracked and probably causing problems in an audio path. So I've just been going through and inspecting and cleaning and resoldering where I see bad stuff. Yeah, a lot of this is just terrible. Terrible build quality is just horrible. See, if you take, let's do a, show you here. I'll go back to one of these pads and let's add solder to it and see how they react. You really got to heat it up before it starts to flow, and then once it starts to flow, you can see how the solder creeps across. That's the action of the flux and the alloy. See, now that's a proper joint. Not this. This here is not a proper joint. If this was a pin, a hole with a lead through it, this wouldn't even solder. But let's try this one. See how it flows across as it heats up. So I'm guessing there wasn't enough heat on this board when they soldered it. And yeah, it's just a mess. So I pulled this connector off because I figured I was going to just straighten out some stuff. It looks like it's bent on the back here. You can see this one's pointing out more than the others. And I thought if I could just push it in, but I think we got bigger problems than that. Somebody replaced this lever, this black lever. I don't know if you can see it. It looks different than the others. It's not the same, and it's not from this machine. It's even got a different spring. So this thing broke, and then somebody tried fixing it. See how it sticks open? It doesn't work. I don't know if there's any fixing this. See, that pulls out. That's not right. These ones don't. So I have a solution though. Come up with another one. This is off some other machine, I don't know what, but it's got the locking. And best of all, the mounting holes are exactly the same width apart, and it has the same profile, the same everything. So this should just fit right in. Let's see. So hopefully this thing can fit in. Yeah, it's a little, the hole's a little tight. I'm gonna have to open the hole up a bit, but I think this is gonna work. And I'll pull the wires off and attach them to this board instead of using this board because the pinout's a little different. So I'll just swap boards, swap connectors, and I gotta open this up a little bit. Just a little bit of file work on the inside here. I think we'll open it up. And that will fix that. Yeah. If I measure it, it's probably like 1/2 millimeter or so, not even in. You'd probably force it, would probably go, but I don't want to do that. Yeah, I'll fix this up and get this together. So here's a look at it installed. I think it looks pretty good. It's not bad. Improvement from what was there, and it works, so we're going to go with that. Alright, I think we're ready for first power up. Now, if I remember correctly, we had DC offset on the left channel. I don't know if there's anything on the right channel. We're going to find out here quick if we still have a problem with our amplifier. So there's our power consumption. Let me put this somewhere so you can see it. Okay, it's turning it on. 28 watts. Our protection went out of protection. Power lamp and soft clipping lamp is on. So let's switch on the speakers. Still got DC. Let me see if we get signal. Yes, we do. We got DC on both sides. Let's measure that and see. Why is it going up to 30? 30 watts. That was a hell of a big difference from when we first powered it up. I think it was around 80 watts. Let's see what's going on with this DC on the input. Do we got a big problem in the amplifier still? Okay. These new connectors, I can't just jam leads in. Maybe I can. Okay. So we got about 200 millivolts on the left channel. Let's see the other channel. Okay, here's the other channel. Turn the speaker on. 4 volts, 5 volts. That's wild. Okay. We still have a problem. So let's tie into this. Let me see if I can get a schematic and figure out what's going on with this thing. So I think the first step here is I need to go through and check power supplies, because I really haven't done anything to this other than replace caps. I did a few things in the protect circuit, but this is what I'm working with here. I got this blurry photograph and I blew it up as big as I could, but it's still blurry. You can't read it. It's going to give me an idea of what to look for in the power supply. And this is the power amplifier. It's a little better. But I'm going to go through and poke through and see if I can figure out if there is an imbalance between these positive, negative voltage supplies. And if there is, that might be the cause of our imbalance. So let me go through that, and I'll do that first, and I'll let you know what I find. But I have a feeling it is power supply related. There's a lot of cooked stuff going on around here that was just baked, and we fixed up a lot of it, but there still might be some more lurking. Alright, so here's a little look at what I found out. This power supply here provides plus and minus, I think it's 44 volts, but I can't really read that. What I measure is two different things. I measure plus 50 volts on this rail, negative 53 volts on that rail. There's a 3 volt difference between the two. This one, I got a 780 millivolt drop across this resistor, which means this is consuming 78 milliamps at 60 volts, and this one here is 38 milliamps. So there's a huge imbalance there too. Now there's an IC here. It's an M5231, I think it's called. It's like a little 5-pin device, and it looks like a voltage regulator of some kind. This might be the problem, but I don't know. It seems like it's working. It's maybe I got a value of a resistor that's out of whack here, and these two aren't tracking the same. So I need to find myself a better schematic. This is just a joke. It's all one big blur, and I can't read anything. I can see the components, but I can't read any of the values or what it's supposed to be. So I'm going to see if I can hunt down another schematic. Okay, I went through this circuit here and checked everything over, and as far as I can tell, everything is what it is. It's working. We have 3 volt difference between the positive and negative rails. I don't know if that makes a big difference, but it seems like everything's working as it should. The 3 volt difference might be there's a divider network right here. We got 247K resistors, and then they're tapping off the middle here and providing voltage for this base. Now I think this might be off a little bit. It doesn't read 0.6, it reads something else. It's close, but it's not quite. So I might have one of these 2 resistors out of tolerance. I checked them, but they're fine. But for whatever reason, this thing's 3 volts off. But I don't think that's the problem. So I was looking at the service manual, and without realizing it, there is an adjustment for offset, and it's up here, VR 601 and 602, I think. This VR sets up the 0 point for the amplifier. This VR sets up the bias. So I went and checked on which channel was I doing? I was doing the right channel, and I'm able to adjust the center point, and I set it from 180 millivolts back down to 0 using this potentiometer. On the other channel, adjusting this has no effect whatsoever. So there is a problem here, somewhere here in this circuit. Could be a transistor, it could be a resistor, it could be a diode. So I'm going to poke around here and see if I can find out why this VR doesn't adjust the bias on the amplifier. So give me a minute to do that. Yeah, and I think I might have already found the problem. This VR 601 is, let's see here. Let me show you. 601 is 500 ohms, and then there's a 1.5K across this variable resistor, and then there's the adjustment. So I measure across this VR, I should get something less than 500 ohms, but I'm not. I'm getting, I'll show you if I can get in here. This is really difficult to, it shows 1.5K. So that VR is open. That is probably the issue. So let's remove that VR and we'll test it out of circuit and we'll replace it if it's bad. Yeah, this VR is open. Look, it's measuring mega ohms, and I'm measuring across the two terminals, which should be 500 ohms there. It's jumping all over. So I'll replace this and we'll get our zero balance back. Okay, trim pot's been replaced. Let's do our balance test and balance adjustment. Turn this thing on and let it stabilize. This is, I think this is the left channel, my right channel. I'm not sure which one is which. But we got 47 millivolts. And let's adjust. Where is the pot? See, this thing's so difficult to work on. It's just got parts thrown everywhere and it's not laid out very well. Try turning this down to 0. Very touchy. Getting close to 0. 6. I'll leave it there for now. Let's check the other channel. This is the one that was damaged, or not damaged, but way out of whack. So now we got 360 millivolts. Let's turn it down. I don't drop my screwdriver and short everything out. Six. So much easier to adjust when you got a 10 turn or 30 turn pot. Let's check this one again. 9. Try and get it closer. Oh. Okay, just banging it around, brought it in. Alright, now we want bias. So let's see what we got for bias on this channel. 2.9. I think the spec is 11, if I'm not mistaken. So let's turn up. Where is the bias pot for this channel? So poorly laid out. VR603 I'm looking for. I don't see it anywhere. VR603, where are you? I see 604. Oh, here's 604. No, it's the one I want right here. Let's turn this up to 10. Doesn't want to adjust. Got another bad trim pot here. There we go. Okay. It's just dirty. Give it some deoxit. Just going to work this trim pot. Alright. Now, let's adjust this to 10. Still dirty. There. Okay, the other channel. You got 6. Okay. The problem with these open trim pots is they get flux all over them, and then they kind of get glued in one position and they lose contact. See, now I lost. Try getting it better than that. There we go. Okay, I'll let that idle and then I'll come back and check it. Alright, we're wired in to do a power test here. So let's get this started. I plugged in to turn it on. Now I have speakers connected to B, so let's see if I can figure out. I'm just going left and right here. Doesn't sound like I have any separation though. Okay, maybe I got them connected backwards. I don't know. Treble, bass, muting. So everything looks like it's working. Let's shut that off and let's turn up the volume and see what this thing can do. Oh, it's clipping already. Okay, let's... somewhere is about there, I think. Right here. Right there. 21.86 volts RMS on the output. Let's turn this timer on and we'll just let it cook for 10 minutes. See how it likes that. Full power consumption, we got 225 watts going in. And I just want to measure, if I can, I want to measure the rail voltage, but I don't know where I can measure it from. Let's see. Full load is 70.5 volts. Let me turn off the signal for a second. No load is 82.2. Okay, we're at the 10-minute mark. I'm just going to do some readings here if this will work. Yeah, we're 55 degrees. 55 across the heat sink, which is pretty good, I guess. It didn't blow up. Some of these other heat sinks are at some pretty good temperatures, down around 30s. This one's up at 40, 45. This one's at 50, 45 or so. So it's doing pretty good. I'm going to turn the volume down. You did pretty good on the 10-minute torture test, so get rid of this. Now let's check a few square waves. So let this cool down for a bit first, and then we'll get looking at some square waves. See, in idle we're down at 27 watts, which is pretty good for this. I can't remember what we measured when I first plugged it in, but it was pretty high. Okay, here goes some square waves, 1000 hertz tone. And we have our control set to center. Okay, going up in frequency. Ten. 15. Starting to lose it. Let's keep going. Yeah, we lose it. That's 22, 23. It's lost it around 15 square wave. Let's go down. ,200 hertz, 300 hertz, or 100 hertz. We're losing our not the greatest low end response. Let's go a little farther. 90, 80, 70. Yeah, 50 hertz. Looks terrible. Okay. Alright, there it is. It's finished. I'm glad it's done. I want it off my bench. I'm not happy to work on these NADs. There's just so much poor construction and poor build quality. That's usually when I'm fighting. So here's all the caps I replaced. A lot of these were dead. You know, a few resistors that were out of tolerance. I replaced a bunch of them. Oh yeah, and I guess the big story for this one was the dead caps and the open trim pot that caused about 5 volts of offset on the one's channel. That's been replaced and repaired. So yeah, these sound great when they're fixed up, but when they're not fixed up, I don't know where they belong in the landfill. I'm gonna get flack for that, but I know there's some people that love it. Okay, I'll shut up now. Yeah, that's it for this one. I'm gonna wrap this up. I'm gonna get it back to the owner and work on something else. I got lots of stuff coming up, so stay tuned. Thanks for watching.